Hello, my name is Marion Schmitz and I work for the NED project. NED is the NASA IPAC Extragalactic Database. NASA, and that's where we get our funding from, and because we are a NASA project, the services we provide are free to anyone with internet access. IPAC is the Infrared Processing and Analysis Center, which is where we are located as part of Caltech in California, Pasadena, California. Extragalactic means that the objects that we are focusing on are outside of the Milky Way galaxy. Things like stars and planetary nebulae and globular clusters that are within the Milky Way are not our primary source of interest, but instead we have galaxies, quasars, clusters of galaxies, and we have a database. At present, which is January of 2015, we have about 218 million objects in the database. So not only do we have the database that people can query, but we have an interface that can find out what information is in that database. If you were to access the URL given here, ned.ipac.caltech.edu, the home page that you would see would be this one. And the way to query the database is by clicking on one of the possible options, and the information in the database contains names, positions, redshifts, diameters, magnitudes, links to the literature as to what papers have published which objects. There's information on the spectra and images. There's a lot of information in the NED database. To show you how to do a search within NED, one can click on the by name functionality and enter a name that's well-known, such as, or well-known or even not well-known, such as M31. And you may then submit the query, and you'll notice that although I typed in M31, the query itself was performed on Messier space 031. The exact format of the name that you're asking for does not have to match the exact format in our database. The information that you will get is shown on a summary line, which gives the object name, the highest rank name that we have at present, the J2000 coordinates for that object, what type of object. Here it's listed as a G, meaning that it's a galaxy, the radial velocity, negative 300 kilometers per second, which is the equivalent to a redshift of negative 0.001001. Optical magnitude, the total optical magnitude for Messier 31 is 4.36 is given in this field. And then we also indicate that NED knows about 3,700 different papers that significantly mention Messier 31 in some regard. We have many individual notes that come from the literature, photometric data points, 147 of them, which we have homogenized all together to generate a spectral energy distribution plot. Positions, velocities, we get more detailed information as we go across the page. Toward the right, you'll see that there's images, and you may retrieve different images that we have on NED by clicking on that word, retrieve, and you'll see a list of the images that we have available, which are, if they are delivered to us in FITS format, we present them in FITS format so they can be downloaded and used by scientists in that regard. These images can come from the Palomar telescope, from GALEX mission, radio telescopes, whatever the astronomer finds of interest and would like us to present on our screen, we will accommodate and put the images in our service. Button next to the images were the spectra, and you may retrieve those, and you'll see that on the left side we indicate where the aperture was placed when the spectrum was taken, a preview of what the spectrum looks like, and then other details on how you can get the data yourself by clicking it, by doing a scientific analysis, full description of what's in the headers for the FITS files of these spectra, and many other aspects. On this main page, the first page that shows the summary information, if you scroll down further, you'll get a list of all the different cross-identifications that M31 is known as. And you'll notice that the Andromeda Galaxy is also listed in here. Had you typed in Andromeda Galaxy instead of M31 at the beginning, you would have gotten the same results. They're considered cross-identifications and aliases for the same object. But you'll also notice that there are all of these other unusual types names, many different catalogs. When they first do the survey, they're not aware of what they're detecting, so they know that they've detected an infrared source. After the survey is finished, or during the processing of the data, they then realize that it's the same as M31 in this case, but they keep the original nomenclature that they used when they did their survey. So there will be coordinate-based names, there will be names that are part of a list. This KTG, for example, is the Kerenshev triple galaxies, which means that there are 3 galaxies together, and this is the C component of those 3. You'll also notice that each of these acronyms has a link applied to it. So if you don't recognize a particular acronym, you may click on that link, and you'll get a new screen which will explain that 2PBC is the second Palermo Swift Bat Hard X-ray catalog. It contains X-ray sources within it, and you can find the literature reference code where to find more information about that catalog. If you want to download the entire catalog yourself, there's a link provided here to Strasbourg, France, which will let you get your own copy of that particular catalog. Scrolling down further from that first main summary page, you'll see a list of coordinates for M31. These are all the same position on the sky, but there are different equinoxes, there are different reference frames. So we have equatorial in B1950, which used to be the popular way of representing coordinates, but come the year 2000, astronomers converted to a different system because precession was taking over, and B1950 was no longer applicable. So we now use an equatorial J2000 system. We also have the coordinates given in elliptic, ecliptic, galactic, and supergalactic coordinates. All of these have a different use by different astronomers, and we try to accommodate each of those astronomers. Scrolling down further, there's a section called Redshift Independent Distances for M31. And for this, we have 272 different distances, which were determined by many different methods. The mean of these 272 distances is what's called a distance modulus, and for M31, it's 24.46, which is also equivalent to a distance from the Milky Way of 0.786 megaparsecs, for those who understand the distances. To see which values actually went into this mean value, you can click on View 272 Methods, and you'll notice that there are the order on these may not be strictly alphabetical, but the methods include carbon star determinations, Cepheid distance scale. The Andromeda Galaxy was used quite a bit for distance determination by the Cepheid method, color magnitude diagrams, and many different methods. Again, the information that we have in our database all comes from the literature somewhere. So we always have a link to the reference code to tell where the data that we have in our database originated. A quick way of reading this reference code is to see that the first 4 characters are the year of publication. The next 5 characters is the journal, astronomical journal or astrophysical journal, astronomy and astrophysics, whatever the journal might be, followed by 4 digits for the volume. In this case, it's volume 129, and then the page number within that volume, 2670. The last character is the first letter of the first author's last name. If you notice that these are all also clickable, so clicking on one of these references brings up a new window, and it includes the abstract for the paper. It gives the title, the authors, and the abstract as published by the authors. There's also a link here to ADS Abstract, which is the astrophysics data systems, and they have a much more detailed information about the articles themselves. You may download an HTML version or a PDF of the article. ADS is a separate project from NED, but we do link and work quite closely with them. From that home page, we can scroll down a little bit further, and we see that we have many different types of classifications for M31. In that T, it means that it's included in a triple according to this 1937 paper. And you may remember that I clicked on KTG acronym, which was a catalog of triple galaxies. This confirms independently the triple nature of the Andromeda Galaxy. Kinematics, there's H1 line width information, the luminosity class, morphologies, as in spiral, Tully-Fisher. There are many, many different classifications available, and in fact we have 198 detailed classifications in NED for M31, and if you want more information you may click that and go further. Scrolling down, we get into more research-based information, such as the foreground galactic extinction in the direction toward M31, and just the further down you get in scrolling, you'll get into more scientific information that we have available. At the very bottom of this home page, you'll notice that there are external archives and services that we provide, and this is links that NED has for services such as Simbad, the GALEX mission, URSA, the MAST, which is a service at Space Telescope, high energy missions, and HESARC, which is at Goddard Space Flight Center, Datascope, URSA. So many different external links, so that we don't repeat the same information that they have in those services. We give you links so you can get the data from them. As I previously mentioned, if you type in the URL ned.ipac.caltech.edu, this will be the home page that you will see. This is as of January of 2015. Later this year, we will be having a new service, new interface, which will replace the one that we see here, and you can preview by clicking on this button, or we have another link to the far right, which says New Interface, and you click on this. Clicking on that will show a much cleaner interface that we'll have, which has a one-box method of querying the database. All of the previous functionality that was shown on the single screen is still available, but they're now in pull-down windows. So where I did a by name search before, you can click on the by name and still have that same search capability. Other searches that you can do for the database would be near name, which means that if you give an object name and a search radius, we'll give you all of the objects in the field around the object that you ask for. If you provide a position in B1950 or J2000 coordinates, equatorial, ecliptic, galactic, supergalactic, we'll be able to search the database by that position and get you the objects you want within the position uncertainty, within the search radius that you provided. A new aspect that we'll be having along with this new interface is called Objects with Unprocessed Catalog Sources. And what this means is that there are many catalogs that we currently have in the queue for loading into our database, but they presently have hundreds of millions of entries in them, and we have not necessarily cross-identified them with NED yet. But instead of having them hidden to the user, we'll be allowing the user to do a positional search, which queries the main NED database plus the other unprocessed catalog sources that we have. And at present, this includes the Spitzer source list, the 2MAS point source catalog. It will include the Sloan DR10 release, and many other very large catalogs. As we receive them, we'll put them in as unprocessed catalog sources, waiting to be merged and blended in with the main NED database. Other types of data that you can search on are, as I mentioned, the images, the spectra, the photometry, positions, diameters, redshifts. If you have a particular object you want to know the redshifts for, you can either use M31 has been stored before, or type in a new object name, and let's see what 3C273 provides. And there are 7 different redshifts that have been presented in the literature for 3C273. 2 of them have redshift uncertainties attached to them, and you'll notice that the one that's highest on the list is the one with the lowest redshift. Again, there's always a reference code attached to all the data that we have in the NED database. Other features that will be on the new interface will include the ability to look for references, search for the literature references that we have by object name or by author name. If you click on author name and type in a name such as Abel, you can do the searches and you will get 19 different abstracts that have the name of Abel as one of the authors.